The engineers said the tractor was worthless. Then the farmer fired up his old steam engine. The farm in Hardin County, Ohio, sat on the eastern edge of the Blanchard River Valley, and in the fall of 1968, it held something that most of Hardin County had not seen in operational condition since the early 1930s, a working-case steam traction engine, the kind of machine that had threshed the grain and powered the sawmills and broken the virgin prairie ground of the American Midwest before the gasoline tractor had replaced it, and that had been disappearing into barns and fence rows and salvage yards across Ohio for 3 decades. The machine belonged to a man named August Reinhardt, who was 71 years old and who had been maintaining it in full working order since 1924, when he had purchased it from a neighboring farmer who was retiring the steamwork and replacing it with one of the early Fordson tractors that were then transforming the economics of farm power in the flat Ohio counties. August had been 27 years old in 1924. He had grown up watching steam traction engines work the Hardin County ground since his earliest memory. His father had been a steam thresherman, one of the men who traveled the county each harvest season with a steam rig, contracting the threshing work for the farms too small to own their own equipment. August had learned the steam engine's operation from his father in the specific way that a boy learns work from a man who does it daily. Not as formal instruction, but as the accumulation of mornings and afternoons spent in the presence of the work, absorbing the sequences and the sounds, and the specific physical knowledge that working alongside a steam plant eventually deposits in the hands and the attention of a person who pays careful notice. He had bought the Case engine in 1924 for $180, the price of a machine that the selling farmer had assessed as no longer economically competitive with the Fordson, but that August had assessed on the basis of his father's training and his own 7 years of steam work, as sound and capable of decades of further service if maintained at the standard the machine required. The selling farmer had been somewhat surprised that a buyer existed at all. The general trend in 1924 was in one direction, from steam toward gasoline, and the buyer for a steam engine in that year was not the obvious transaction. August had said, at the purchase, "I know this machine, I know what it needs, I know what it can do." He had been right about all three. The Case engine had worked the Reinhardt farm from 1924 forward, not as the primary field tractor, which role the gasoline tractors had taken over on the Reinhardt acres by the late 1920s, but as the stationary power plant that the farm's threshing and the sawmill work and the grain elevator operation required. The machine's belt pulley drove the threshing separator during the harvest season, and drove the sawmill that the Reinhardt farm operated on the timber from the woodlot on the North Quarter, and the custom sawing work that the neighboring farms brought to the mill. A steam plant at stationary power work was, in August's assessment, more economical and more reliable than an equivalent internal combustion plant of any era, not because the steam cycle was inherently superior, but because the steam engine's working principles were simpler in the specific ways that mattered to a farm operator who maintained his own equipment. The wear failure modes were slow and visible before they became catastrophic, and the fuel, wood from the farm's own timber and coal, from the Hardin County coal merchant, was always available and always within the farm account's budget. He had said this to his son Werner in the mid-1940s, when Werner had asked why the Case engine remained in active service, while every other farm in the valley had scrapped its steam equipment a decade earlier. August had said, "Because I know how to maintain it, and it knows how to work." An engine that is understood by the man who runs it and maintained by the man who understands it will outwork any replacement that neither knows nor is known. Werner had been 16 then, and had absorbed the principle in the way that 16-year-olds absorb principles from fathers they respect, not with full comprehension, but with the specific retention that later experience fills in. Werner had been working the farm since 1958, when August's age had made him the primary manager of the field operation, while August continued the steam engine work that required the specific knowledge only he possessed. The division of labor had been natural and unspoken. Werner handled the field tractors and the modern equipment. August handled the case engine and the beltwork it powered, and the farm operated as a coherent whole in which both sets of knowledge were necessary and neither was subordinate to the other. The Ohio State University Agricultural Engineering Department conducted its equipment utilization studies in Hardin County in the fall of 1968 as part of a broader survey of farm power usage patterns across the state. And the team that came to the Reinhardt farm was the same kind of team that had visited farms across the county. 2 engineers, professional training, field notebooks, the specific framework of institutional assessment that had been shaped by 3 decades of post-war agricultural mechanization research. They had not expected to find an operational steam traction engine. The survey instrument had not included a category for steam power because steam power had been categorized as having passed from Ohio agriculture in the early 1930s. The Reinhardt farm was an anomaly the survey had not been designed to encounter. The lead engineer's name was Patterson, and he was 43 years old, and he had written his graduate thesis on the economics of farm power transition in Ohio during the 1920s and 1930s, the period when the steam engine had been displaced by the gasoline tractor. And he knew the technical specifications of steam traction equipment in the way that a man knows the specifications of a technology he has studied in historical context. He knew what a case steam traction engine of the era the Reinhardt machine represented was supposed to be capable of. He did not know, when he walked into the Reinhardt equipment shed in October of 1968, that he was about to encounter one in operational condition 44 years after its purchase and 70-some years after its manufacture. He had been quiet for several seconds when August had walked him into the shed and had let him see the machine. The case engine stood in the shed with the specific presence of steam-era machinery. The boiler, the firebox, the flywheel, the belt pulley, the drive wheels, in the condition of a machine that had been maintained not as an artifact, but as a working tool. Not restored to cosmetic condition, not painted and polished for a museum. Maintained in working condition, which meant oil where oil was needed, gaskets where gaskets required attention, fire tubes cleaned on the schedule that the boiler's working pressure required. The governor overhauled in the winter of 1959, when Werner had noted a response lag in the belt drive speed under variable separator load. Patterson had asked August how long since the machine had been fired. August had said, last week. Werner and I ran the sawmill through Thursday. We had a neighbor's timber to cut. Patterson had said, the machine is operational. August had said, I would not keep it if it were not. The second engineer, a younger man named Corrigan, who had been 3 years out of his graduate program, had been taking notes and had said, are you aware that there are no other operational steam traction engines in active farm use in Ohio that we know of? August had said, I am not aware of the others. I am aware of this one. Patterson had asked whether he could observe the machine's operational start-up and run, and August had said yes, but that it would need to be tomorrow morning because raising steam required time and the hour was already past noon. They had arranged to return at 7 the following morning. August had fired the case engine at 5:30 in the morning, 2.5 hours of fire preparation before Patterson and Corrigan arrived at 7, the specific preparation time that a cold boiler required to reach working pressure without thermal stress that compromised the boiler material. Werner had been in the shed from 5, handling the fuel and the water, while August managed the fire and the pressure build-up, the two of them working in the practice coordination of a team that had been doing this specific work together for a decade. Patterson and Corrigan had arrived at 7:10 to find the engine at working pressure. The safety valve, showing the specific behavior of a boiler properly maintained to its rated pressure. The valve seated, the steam contained, the pressure gauge reading the working range. August had demonstrated the startup sequence from cold boiler to working pressure, walking Patterson through each step and explaining the thermal management principles that the sequence was designed to address. The rate of fire increase relative to the boiler's thermal mass, the water level management during the pressure build-up, the specific valve sequence that allowed the boiler to equalize temperature before full operating pressure was reached. Patterson had listened with the attention of a man who knows the theory and is watching the practice for the first time in operational context. He had known the startup sequence from his historical research. He had not observed it performed on a functioning boiler in the living memory of his professional career. He had said, after August had brought the engine to operating pressure and had engaged the belt pulley, "How long have you been operating this machine?" August had said, "Since 1924. 44 years. Patterson had said, "And before that, your father." August had said, "My father operated a different case engine, a larger one, from 1898 to 1921. I worked with him from 1908 onward. I have been in the presence of this type of equipment for 60 years. Patterson had said nothing for a moment. He had been in the presence of a man who had 60 years of operational knowledge of a technology that Patterson had studied as a historical subject. The gap between historical knowledge and operational knowledge was visible in the exchange, and Patterson was a man honest enough about his own understanding to recognize it when he encountered it. The second engineer, Corrigan, had asked about the maintenance record. August had taken them to the farm office and had produced the record, not a composition book service log of the kind the Kaufman farm had maintained for its Farmall regular, but a more comprehensive document, a 3-ring binder that August had assembled over the decades, containing the original case engine's specification sheet from the manufacturer, the correspondence with the case company's service department across the 1930s and 1940s, when replacement parts had been required, the boiler, inspection certificates that the Ohio Boiler Inspection Authority had issued on the annual schedule that a working boiler required under state law, the specific repair records with the parts sources and the dimensions and the material specifications, and a section that August had titled the operating record, the annual account of what the machine had done in hours and in work accomplished since 1924. The boiler inspection certificates were the element that had most interested Patterson. The Ohio Boiler Inspection Authority had been visiting the Reinhardt farm annually since 1924 to certify the case engine's boiler for continued operation under the state's boiler safety regulations, and the certificates formed an unbroken chain of official documentation that the boiler had been in compliance with the state's safety standards every year for 44 years. The certificates also recorded on the inspection form the boiler's condition at each annual inspection, the fire tube measurements, the shell thickness readings, the valve condition, the safety valve calibration. 4 decades of the state's own measurement record on the machine's boiler condition. Patterson had read through several years of the inspection certificates. He had said, "The boiler has been inspected and certified every year since 1924. August had said, "It is a steam boiler operating in Ohio. State law requires annual inspection. I have never missed an inspection." Patterson had said, "The condition notations in the later inspections show the boiler in better condition than in some of the earlier inspections." August had said, "The 1951 retube. The fire tubes were at the end of their service interval, and I had the boiler shop in Lima do the complete retube that year. New tubes, full inspection, hydraulic test before return to service. The inspector in 1952 was reading a substantially renewed boiler. The condition has been stable since." Corrigan had asked, "Where does a farmer find a boiler shop capable of retubing a steam traction engine boiler in 1951? August had said, "I found one in Lima that had been doing industrial boiler work since before the First World War. The man who did the retube had been doing boiler work since 1919. He knew what the case engine's boiler required. It took him 3 weeks and cost $340. The boiler has been right since." This exchange had captured something that Patterson had been thinking about since the previous morning, when he had first seen the case engine in the equipment shed. The specific network of knowledge and service capability that keeping an operational steam engine in the 1950s and 1960s required was not simply a matter of an individual farmer's stubbornness or sentiment. It was a matter of sustained relationships with the specific craftsmen and services and supply chains that the technology required. Relationships that August had maintained across 4 decades because the maintenance of the technology required the maintenance of the relationships. And because he had understood since 1924 that the technology's survival in his operation depended on his ability to support its survival in the broader service ecosystem. The boiler shop in Lima. The parts correspondent at the case company's service department continued across 3 decades and 2 changes in the department's personnel. The coal merchant in Hardin County, who had maintained a small steam coal supply alongside his primary trade, specifically because August Reinhardt was a reliable annual customer, and because one reliable annual customer was sufficient justification for maintaining the supply capability. The Ohio Boiler Inspection Authority's annual inspector, who had been the same man from 1934 to 1963, and whose specific knowledge of the Reinhardt machine's condition history had been a form of institutional knowledge that August had valued and that the inspector had valued in return. These relationships were not in the maintenance record, except implicitly in the names of the parties to the repairs and the inspections. They were in August's knowledge of who to call and how to ask and what the work required, accumulated across 4 decades of keeping the technology operational in a world that had decided the technology was obsolete. Patterson had asked in the farm office what August had done when the case company's service department had stopped carrying replacement parts for the steam engine line. August had said, "I wrote to them in 1947 when I needed a new governor weight assembly. They told me the parts were discontinued. I wrote to a machinist in Columbus who had been making reproduction parts for stationary steam equipment since the 1930s, gave him the dimensions from the original specification sheet, and had the parts made. They cost more than the originals would have, and they have worked correctly since." Corrigan had said, "You had them machined." August had said, "When you cannot buy the part, you have it made. When you cannot have it made locally, you find the man who can make it at the distance. When that man retires, you find the next one. The technology does not have to be discontinued if the knowledge of what it requires is maintained, and the will to maintain it is present." This was the specific principle that the farm office conversation had been circling toward for 2 hours. Not the maintenance record, not the boiler certificates, not the machinist correspondence, but the underlying principle that all of these documents expressed. The technology's operational life was not determined by its age or by the institutional decision to discontinue it, but by the specific decision of the person who operated it to maintain the knowledge and the relationships and the will that its continued operation required. August had made that decision in 1924 when he had bought the case engine from the neighboring farmer who was retiring it, and he had continued making it every year since. The annual boiler inspection, the machined parts when the original supply was discontinued, the relationship with the Lima boiler shop, the care of the fire tubes and the shell and the valves and the governor and the firebox that the machine's safe and reliable operation demanded. Patterson had asked near the end of the farm office conversation, why? August had said, why what? Patterson had said, why maintain this machine when the technology has been replaced? when the internal combustion engine does the same work with less complexity and a larger part supply. August had been quiet for a moment. He had said, "The belt work this machine does, it does at the torque and the speed consistency that the threshing separator and the sawmill require. I have operated internal combustion belt power on comparable belt work, and I know the difference in the power delivery characteristic. The steam plant does not surge. It does not cavitate under sudden load. It delivers what you ask it to deliver at the speed you set the governor to deliver it, and it continues delivering at that speed regardless of the variation in the belt load. The separator and the mill reward that consistency in a way that the yield and the lumber quality reflect." He had said, "Also, I know this machine. I've known it for 44 years. I know what sound it makes when it is correct and what sound it makes when something has changed that I should investigate. I know the feel of the governor's response and the behavior of the safety valve and the rate at which the water glass reading drops under various load conditions. This knowledge took 44 years to accumulate. It is not transferable to a different machine without beginning the accumulation again." Corrigan had written in his field notebook, "The operator's longitudinal knowledge of a specific machine is itself a form of investment that influences the continued operation decision independently of the technology's comparative efficiency." August Reinhardt is not operating the Case steam engine because it is technically superior to the alternative. He is operating it because 44 years of accumulated knowledge of a specific machine is a form of capital that does not transfer to a replacement without substantial loss. This notation had become part of the 1969 extension report that Patterson and Corrigan had produced from the Hardin County field study, though the notation in the report was somewhat more formal and less direct than Corrigan's field notebook version. The report had described the Reinhardt farm as a case study in extended equipment life through operator expertise and sustained maintenance relationships, and had noted that the economic analysis of equipment replacement decisions in working farms should account for the operator knowledge capital that accumulated over long-term machine relationships and that was not recoverable in a replacement decision. The report had been modestly influential in the Ohio Extension Service's equipment guidance, not dramatically, not in a way that changed the fundamental direction of the service's recommendations toward modern equipment, but in a specific way that the 1964 OSU paper on equipment assessment protocols had also been influential. It had added a consideration to the framework that the framework had not previously contained, the recognition that the relationship between an experienced operator and a specific machine was itself a measurable economic variable that the standard replacement cost analysis did not capture. August had not read the report. He had not known that his conversation with Patterson and Corrigan had produced any institutional outcome. He had continued farming the Hardin County ground with Werner and had continued operating the Case engine on the beltwork through the early 1970s, when his age had made the physical demands of the steam engine's startup and operation something that Werner needed to be more centrally involved in. Werner had been learning the steam engine operation since his mid-teens, watching his father at the firebox, learning the pressure build-up sequence, developing the specific sensory knowledge of what the machine sounded like at correct operation and what deviation from the correct sound indicated about the machine's condition. The learning had been slower and harder than it had been for August, because Werner had not grown up as immersed in steam culture as August had. The steam thresherman tradition of August's father's generation was not Werner's generational background, and the steam engine's operation required the development of sensory knowledge that had no shortcuts and no classroom equivalent. But Werner had learned it. By 1972, he was capable of the startup and the fire management and the pressure regulation and the beltwork supervision that the Case engine's operation required, not at the level of his father's 60-year fluency, but at the level of competent, careful operation, supported by the knowledge of what he did not yet know instinctively, and what therefore required the specific attention that the documentation in the three-ring binder provided. He had said to his father in the equipment shed after a threshing run in 1972, "I can start it and run it. I cannot yet hear everything you hear." August had said, "You will hear more each year. The engine teaches hearing over time. I heard what you heard when I was your age. I hear more now because I have been listening for 48 years. Werner had said, "What should I listen for that I am not yet hearing?" August had said, "You will know when you hear something you have not heard before. Until then, follow the documentation. The documentation tells you what to do. The engine teaches you what it sounds like. The documentation and the engine together will get you through the seasons until you have enough of your own history with the machine to hear what I hear." This exchange had been written in the three-ring binder's operating record section in Werner's handwriting in the fall of 1972, alongside the annual threshing hours entry. Werner had been maintaining the operating record in his own handwriting since 1968. August's eyesight had been declining since the mid-1960s, and the writing of entries had shifted to Werner, while the operational knowledge had remained primarily August's, until the years when Werner's growing competence and August's aging energy had reversed the proportion. August had died in 1976, at 79 years old, in the farmhouse on the Blanchard River Valley edge that had been his home since birth. He had died in the late fall, after the threshing season, which was the way a steam thresherman's son who had spent his life working the steam engine died. After the work was done, in the season when the engine was banked and the boiler cooled and the shed doors closed until the spring fire preparation, the last entry in the three-ring binder's operating record in his handwriting was from the fall of 1971, the season before his eyesight had made Werner the writer of entries. The entry had noted the season's threshing hours and the belt work hours and the fuel consumption, and had added one line, "Machine in correct condition for winter storage." Werner had found that line in January of 1977, reading through the binder in the months after his father's death, in the way that sons go through a father's records when the father is gone, and the records are the remaining account of the father's knowledge. He had found the line and had understood its specific character, the economy of expression that a man who has been making the same kind of entry for 47 years develops when the entry is confirming what he always confirms, and the confirmation is the point rather than the elaboration. Machine in correct condition for winter storage. 47 years of seasons, 47 entries confirming the correct condition. The last one in 1971, written by a man who was 74 years old and whose eyesight was declining and who had been doing this specific confirmation since 1924. Werner had continued the operating record from 1972 in his own handwriting and had continued it through the 1970s and into the 1980s, operating the case engine on the annual belt work, the threshing that the Reinhardt operation still did for neighboring farms that had kept their grain standing through the fall, and the sawmill work that had become a significant part of the farm's income as the Hardin County timber market had developed in the 1970s. The engine had operated through these years in the condition that the annual boiler inspections confirmed, stable within the working parameters, the retube of 1951 holding and the fire tube showing the slow wear that correctly operated boilers of the era showed under careful management. The case engine had been the subject of a second engineering visit in 1981, when a team from a different OSU department, the Industrial History Program, not the Agricultural Engineering Department, had come to the Reinhardt farm to document the machine as part of a study on the survival of pre-World War I industrial equipment in working use in Ohio. The team had found Werner operating the machine on the beltwork for the sawmill and had spent 2 days documenting everything: the machine specifications, the maintenance record, the boiler certificates, the machine parts correspondence, the operating record. One of the industrial historians had asked Werner what he would do when the Ohio Boiler Inspection Authority eventually decided that the machine's age precluded certification. Werner had said, "I have asked the inspector about this. He has said the Ohio Boiler Code addresses the machine certification on the basis of its current condition, not its age. The condition has been acceptable at every inspection since 1924. As long as the condition continues to be acceptable, the certification continues." The industrial historian had said, "And when the condition is no longer acceptable?" Werner had said, "Then I will address the condition. My father had the boiler retubed in 1951, when the tubes reached the end of their service interval. If the shell needs attention, I will find the appropriate shop and have the shell given appropriate attention. The documentation tells me what the machine requires, and the boiler inspections tell me where it currently is relative to what it requires." He had said, "My father maintained this machine for 52 years from the day he bought it. I intend to maintain it for at least as long from the day I took over primary responsibility. The industrial history program is welcome to document it, but the documentation is not why we maintain it. We maintain it because it works, and because we know how to work it, and because the work it does is useful, and because to stop maintaining it would be to let 48 years of my father's knowledge go silent in a shed, rather than continuing in the world." The industrial historian had written this in his field notes verbatim, and it had appeared in the 1982 study report with attribution to the Reinhardt farm, identified by county but not by name. The passage had been quoted in a subsequent paper on the economics of heritage technology maintenance, published by the Ohio Historical Society in 1984, and had become one of the more cited passages in that paper's specific argument that working maintenance of historical technology produced both economic value and a form of knowledge preservation that museum-style preservation could not replicate. The argument was the argument August had been making since 1924, without knowing it had an academic context. A machine in working condition, in working use, is different from a machine in a museum, because the working machine continues to be known by the people who work it, and continues to teach the people who maintain it, and continues to produce the work that the people who use it require. When the machine stops working and enters the museum, the knowledge that working it produces goes with it, and what the museum preserves is the object without the knowledge that the object generated. August had known this intuitively. Werner had known it because August had taught it. The industrial historian had known it because Werner had articulated it at the equipment shed in 1981. 3 generations of knowing. The steam thresherman's son, who had kept the machine working since 1924. The farmer's son, who had learned it across 30 years of watching and working alongside his father. And the industrial historian, who had heard it articulated by the farmer's son, and had understood what it meant for the field he studied. The case engine had continued in Werner's operation through the 1980s. It had been the subject of 2 more visits from the antique machinery community in the mid-1980s, when the steam traction engine restoration movement was gaining momentum in the agricultural heritage community, and the word had spread through that community that there was a working, non-restored, continuously operated case steam traction engine in Hardin County, Ohio. The visitors had come from as far as Indiana and Michigan to see it run, and Werner had run it for them with the specific pride of a man who is not performing a restoration, but demonstrating a continuation. He had said to one of the Indiana visitors, "The difference between a restored machine and a maintained machine is the difference between a returned condition and a continued condition. The restoration brings the machine back to a condition it had before. The maintenance keeps it in the condition it has always been in. This machine has never been restored. It has been maintained. There is nothing to restore because nothing has been abandoned. The Indiana visitor had been a steam engine enthusiast who had been restoring pre-war equipment for 20 years and who had heard this distinction clearly. He had said, "You are describing a living machine." Werner had said, "I am describing a maintained machine." Living is a word for something else. Maintained is the word for what this machine is. The Case engine was still operating in Hardin County as of the late 1980s, when Werner's son Carl began learning the startup and the fire management and the pressure regulation in the same way that Werner had learned them from August, in the equipment shed, alongside the man who knew on the mornings when the boiler needed to be fired and the belt work needed to be done. Carl had been born in 1952 and had grown up on the farm with the steam engine as a present and working reality. Not a relic, not a museum piece, not a historical artifact, but a machine that fired up every threshing season and powered the sawmill and produced the specific sound and the specific smell and the specific presence that a working steam plant produces in the space it occupies. He had asked Werner in the early 1980s, when he was taking on more of the steam engine responsibility, "How do I know when I know enough?" Werner had said, "You know enough when you can answer the question the engine is asking before the question produces a problem. Until then, you know enough to avoid making problems worse. The documentation tells you the threshold between the two." Carl had continued the operating record in his own handwriting from the years when his participation grew into primary responsibility, the third generation of Reinhardt handwriting in the three-ring binder that August had started in 1924 with the Case engine's original specification sheet. 3 generations of the same document, maintained in the same format, recording the same kind of information about the same machine across a span of time that no engineering study had been designed to encounter when it first arrived at the Reinhardt farm in the fall of 1968 and found a working steam traction engine where the survey form had no category to record it. Patterson had retired from OSU in 1984. At his retirement, he had mentioned the Reinhardt farm visit to his colleagues as the field experience that had most changed his understanding of the relationship between equipment technology and the knowledge that operating it produced. He had said, "I went to Hardin County in 1968 to survey farm power equipment and found a man who had been operating a steam traction engine since 1924. I had written a thesis on the period when that technology was being replaced. I knew the specifications and the historical context and the economic argument for the transition. He knew the machine. I had studied the subject. He had worked it for 44 years. The subject looked completely different from each position, and his position was the one that contained the information the machine actually required." His colleague had asked what he had taken from the experience. Patterson had said, "I took from it a permanent wariness of the word worthless when applied to technology that someone is maintaining at their own expense and operating in their own interest. Worthless is a market judgment. It says nothing about the knowledge the technology contains or the knowledge the operator has accumulated about the technology or the work the technology continues to do in the hands of the operator who knows it." The Case steam engine in Hardin County was worthless in the market sense from approximately 1935 onward. It was not worthless to the man who had been maintaining it since 1924 and who fired it up for us in October of 1968 and walked us through the startup sequence and explained what he was doing and why. He had said, "I had a framework for the technology as historical subject. He had a framework for the technology as working reality. The working reality contained more information than the historical subject, and the information in the working reality was the information the machine required in order to continue being what it was. The steam plant in the Reinhardt equipment shed had contained that information since 1924. It had continued containing it through Werner's operation and Karl's learning and the three-ring binder's third generation of entries. The engineers had said it was worthless. The farmer had fired it up in October of 1968 and had walked them through the startup sequence, and they had watched the boiler come to working pressure and the belt pulley engage and the engine run at the governor's set speed under the belt load, smooth and consistent, exactly as August had said it would. Worthless. The engineers had used the word and then watched the machine run. The machine had been running since 1924. The machine had been known since 1924. The knowing was the reason it ran. That was the whole account. That was sufficient. That was everything. The boiler cooled. The fire banked. The shed doors closed. Spring would come. The fire would be laid again, as it had been laid since 1924, by men who knew what the machine required, and gave it. That was sufficient. The specific account of the case engine's mechanical character, what made it different from the internal combustion alternatives that had replaced steam power in most Ohio operations by 1930, deserved a fuller treatment than the general description could provide, because August's explanation to Patterson about the beltwork quality was not sentimental and not self-serving. It was a technically accurate description of a real difference in power delivery characteristic that the threshing separator and the sawmill work genuinely expressed in ways that mattered to the outcome. A threshing separator of the era the Reinhardt farm worked, a Minneapolis Moline unit that Werner had acquired in 1954 to replace the older IH separator that had served the farm since the 1930s, required consistent cylinder speed to produce the grain separation efficiency that the threshing quality depended on. The separator cylinder, driven by the belt from the engine's belt pulley, needed to maintain its rotation at a rate that was within a few percent of the design speed in order for the concave clearance and the cylinder's stripping action to work in the relationship the machine had been designed around. When the belt load varied, as it inevitably did when the grain flow through the separator fluctuated between heavy bundles and thin ones, between wetter grain and drier grain, between the easy passes and the heavy ones, the engine's governor response was what maintained the cylinder speed within the required range. An internal combustion engine's governor responded to belt load variation through the throttle mechanism, which adjusted the fuel-air charge to the cylinder in response to the speed signal the governor received. The throttle response had an inherent lag, the time between the governor detecting the speed drop, the signal reaching the carburetor or injection system, the fuel charge adjustment, the combustion event, and the power output recovery. In a properly tuned internal combustion engine, the lag was short and the speed recovery was adequate. But the lag was never zero, and under conditions of sudden heavy load, a particularly dense bundle entering the separator at a moment when the previous bundle had not fully cleared, the lag produced a speed dip that was brief but real, and that the experienced thresherman could hear in the separator cylinder's sound as a momentary decrease in the stripping action's intensity. The steam engine's governor worked differently. The governor in August's case engine, a shaft-mounted centrifugal flyball governor of the classic design, responded to speed changes by adjusting the steam admission valve, controlling the quantity of steam entering the cylinder per stroke. Steam, unlike the gasoline charge in an internal combustion cylinder, was already available at the admission valve under boiler pressure. There was no combustion lag. When the governor detected the speed drop from heavy belt load and increased the steam admission, the response was the response of a fluid under pressure flowing through a valve. Fast, proportional, with the specific smoothness of a well-maintained governor hunting for and finding its set point without the oscillation that a misadjusted governor produced. August had explained this to Werner in the equipment shed in the late 1950s, When Werner had asked why the separator ran better behind the steam engine than it had during the seasons when Werner had watched a neighbor's farm use an internal combustion belt drive on comparable threshing work. August had said, "The steam plant gives the separator what it asks for in the moment it asks for it. The gasoline engine gives the separator what it asked for a moment ago. For slow belt work, the difference is small. For separator work, where the load varies with each bundle, the difference is in every bundle." Werner had asked, "How much does it matter?" August had said, "It matters in the screenings. Watch the screenings pile when the cylinder speed varies. The grain that goes into the screenings pile instead of the clean grain elevator is the grain that went through the cylinder when the speed was not correct. The steam plant produces fewer screenings because the cylinder speed is more consistent. The fewer screenings difference is not large in percentage terms. Over 1,000 bushels of threshing, it is several bushels in the clean grain elevator that would have been screenings behind a less consistent drive. Werner had watched the screenings. His father had been right. The difference was real and measurable in the clean grain versus screenings ratio. And it was the kind of difference that the farmer for whom the threshing was being done noticed when the tickets from the elevator showed the grain grade that the screenings proportion influenced. The sawmill work had a different but comparable characteristic. A sawmill's blade speed needed to be consistent with the feed rate to produce the specific cut quality that the lumber market required in the Hardin County timber trade of the 1960s and 1970s. A blade that was running slightly slow relative to the feed produced a rough-cut surface that required more finishing work. A blade running slightly fast relative to the feed produced waste. The governor's job in the sawmill application was the same as in the threshing application, to hold the blade's speed within the range that the cut quality required, regardless of the variation in the timber's density and grain that made each cut's load requirement different from the previous one. The case engine's governor did this with the same smooth, proportional response that the threshing work had demonstrated. The steam admission adjusting continuously to the load signal, the fly ball weights finding their equilibrium, the blade speed maintaining the set point within the narrow range that the cut quality required. Werner had taken the sawmill's output to the Hardin County lumber buyer across multiple seasons and had heard from the buyer that the Reinhardt cut was consistently cleaner than the comparable timber cut at operations using internal combustion belt power. The buyer had attributed the difference to the feed rate management, meaning the operator's control of how fast the timber was fed into the blade. Werner had not corrected him. The feed rate was part of it. The governor's consistency was the other part, and explaining steam engine governor dynamics to a lumber buyer had not seemed like a productive use of the conversation. Patterson had understood this technical explanation when August had given it in October of 1968, because Patterson's thesis research had covered the specific mechanical characteristics of steam traction engines and their advantages and disadvantages relative to internal combustion equipment. He had understood the governor dynamics. What he had not fully anticipated was that a farmer in Hardin County in 1968 would be articulating the same technical distinction that his thesis had described in historical terms from 44 years of operational experience rather than from library research. The two descriptions, the historical academic description and the operational description, had arrived at the same technical content from entirely different directions, and the convergence had been one of the more intellectually interesting moments of Patterson's professional career, as he had described it to colleagues across the years after the Hardin County visit. He had said, "The farmer explained the governor dynamics in terms that were different from the engineering vocabulary I would have used, and that described the same phenomenon with perfect accuracy. He said the steam plant gives the separator what it asks for in the moment it asks for it. That is a description of zero-lag response to load variation. He did not use the word lag. He used the word moment. The content was identical. Corrigan had added, in the car back to Columbus after the 1968 visit, there is a test case here for whether operational knowledge and institutional knowledge are actually describing the same underlying reality, or whether they are describing different aspects of it. The governor dynamics suggest they are describing the same reality. The farmer arrived at the description from the separator output. The engineering arrived at it from the theoretical analysis of the governor mechanism. Two routes, one description. This observation had found its way into the 1969 extension report in a somewhat compressed form, but the essential point had been preserved. The Reinhardt Farm's operational knowledge of the case engine's power delivery characteristics was technically accurate and described the same mechanical realities that the engineering analysis of steam engine governor dynamics described, from a different starting point and in different vocabulary, but with convergent content. The convergent content had been one of the reasons the 1969 report had been cited in the subsequent literature on farmer expertise and agricultural extension methodology. The specific demonstration that a farmer's operational knowledge, developed over decades of working with a specific technology, could produce technically accurate descriptions of the technology's mechanical behavior that converged with the engineering analysis from the opposite direction. August had not known that his explanation to Patterson had produced a citation in the extension literature. He had been explaining the governor dynamics because Patterson had asked why he maintained the steam engine, and the explanation was the honest answer to the honest question. He had not been making an argument for institutional recognition. He had been describing what he knew from 44 years of watching a specific machine work on specific tasks under specific conditions. The knowing was the point. The knowing was also, as it turned out, the content that the institutional framework found valuable once it had been articulated in the context where the framework could receive it. A steam engine's firebox, tended correctly across a 48-year fire season that spanned from Coolidge's presidency to Nixon's, had generated the specific knowledge that made the November 1968 description technically accurate. The log was in the 3-ring binder. The binder was in the farm office. The office was in the farmhouse, at the edge of the Blanchard River Valley. The machine was in the shed. The machine knew the farmer. The farmer knew the machine. The engineers had learned something they had not come to Hardin County expecting to learn. The firebox had been where the learning began. In 1924, and every November since, banked for winter, ready for spring. That was sufficient. That was the whole account. The steam rose. The governor found its speed. The belt drove the work, as it always had. When the man who knew it was at the firebox, as he had been at the firebox since 1924, that was everything. The 3-ring binder that August had assembled over the decades was a more complex document than the service logs that appeared in other farms of this series, not because the maintenance record it contained was more thorough. The Kaufman service logs measurement sections were arguably more systematic in their quantitative discipline, but because the binder had been built to contain the full technical ecosystem that the steam engine's continued operation required. It was not simply a maintenance record. It was a technical reference library for a technology whose institutional support had been withdrawn decades before. The original case specification sheet was there because August had understood, when he bought the engine in 1924, that the manufacturer's own documentation was the foundation of any subsequent maintenance work, and that as the technology became obsolete, the institutional support that kept such documentation available would disappear before the machine itself did. He had obtained the specification sheet at the time of purchase and had filed it in the binder's first section specifically because he foresaw the day when asking the case company for it would not produce a result. That day had come in 1941, when Werner had asked August whether they should write to Case for the governor's spring tension specifications, and August had said, "We do not need to write to Case. The specification is in the front of the binder." He had been right, and the specification had been there, and the governor's spring tension had been set correctly, and the question had not needed to go to a manufacturer that was no longer in the steam engine business. The correspondence section with the Case Company's service department was there because August had understood that the institutional knowledge of the manufacturer's service people was worth preserving in the documentary record, even as the manufacturer moved away from the technology. The letters from the 1930s and 1940s, the Case Service Department's responses to August's technical questions about specific maintenance procedures and replacement part specifications, preserved the manufacturer's own technical knowledge at a point in time when the manufacturer still had people who knew the answers. By the 1950s, those people had retired or moved to other work, and the Case Company's service department's responses to steam engine questions had become shorter and less specific as the institutional knowledge had dissipated. The letters in the binder's correspondence section were the preserved residue of that institutional knowledge from the period when it had still been available to ask. The machinist correspondence section was there because when the Case Company had discontinued the parts supply, August had found the alternative sources and had documented the finding. The machinist in Columbus, his contact information, the parts he had made, the dimensions he had worked from, the price and the timeline. He had added a second machinist in the mid-1950s when the Columbus machinist had died and his son had taken over the shop, and August had established the relationship with the son the same way he had established it with the father. The documentation preserved the relationship in a form that Werner could use if August were not available to provide the introduction. This was the specific foresight of a man who understood that the network of knowledge and service he had built around the technology was fragile in ways that the technology itself was not. The machine was durable. The people and institutions that supported it were mortal. The documentation compensated for the mortality of the network by preserving what the network had produced in a form that outlasted any individual participant. When Patterson had read through the binder in the farm office in October of 1968, he had recognized this foresight explicitly. He had said, "You have documented not just the machine, but the support system the machine requires." August had said, "The machine requires parts and service and expertise that are no longer commercially available. The documentation preserves where I found the parts and the service and the expertise. Without the documentation, whoever comes after me would need to find these things again from the beginning. The documentation means they start where I stopped, not where I started." Corrigan had written in his field notebook, "The documentation is a form of knowledge transfer that bypasses the requirement for direct transmission between individuals. August Reinhardt's son and grandson can maintain this engine using the binder even if August is not present to teach them, because the binder contains what August found and how he found it, and what it cost and what it produced." This observation had been the direct origin of a paragraph in the 1969 Extension Report about technical documentation as knowledge preservation for equipment in obsolete technology categories. The argument that farmers maintaining equipment from discontinued technology lines had specific documentation needs that differed from the documentation needs of farmers maintaining current generation equipment, because the current generation equipment had institutional support that obsolete technology equipment did not, and the documentation therefore needed to serve as the institutional support that the market no longer provided. August had not needed the extension report to tell him this. He had understood it since 1924, when he had obtained the specification sheet and started the binder's first section. He had been building the institutional support the market was withdrawing year by year into the binder's growing sections for 44 years before Patterson and Corrigan had arrived to observe and describe what he had done. The description was welcome. The doing had happened without it. The machine ran, the binder was in the office, the boiler certificates were in the binder, the boiler was at working pressure in the shed, the belt was driving the work, the governor was finding its speed, as it had found its speed every threshing season since 1924, as it would find it the following season, and the season after that. For as long as a Reinhardt was at the firebox, knowing what the firebox required, and giving it, that was the whole account. Worthless, the engineers had nearly said, before the machine ran. Running, the machine had answered. Since 1924, that was sufficient.